So you've got your nice pretty graph, and in this video I'm going to show you how to use, excuse me, this is a table. I'm going to show you how to use Excel to create a nice pretty graph and to produce all of the graphs required for the IB Physics data analysis section. So the first thing you do, well, you may have noticed, I just want to mention, I've changed these values so that the uncertainty in mass is a little more realistic, 0.3 rather than 0.03. We are going to first produce the initial graph, which has as the independent, as the x value the independent variable, and the y quantity will be the average dependent variable values. So you click on Insert, click on Scatter. We want this scatter plot. There's nothing here, so we have to select data and add a series. Click Add. Again, our x values are the independent variable, that's mass. The y values are the dependent variable, but the averages, hit OK, hit OK. If you have other series in here, remove everything using this button, then add your new series. I'm going to delete the legend. You delete your legends. They're of no use to us. And now, we see our data. Right? So there's some curve to it, but it's not a very big curve, not a lot of curvature. So I'm starting to suspect maybe some kind of power relation, definitely not exponential. So power relation maybe like less than squared, maybe 1.5 or 1.7 or something. I'm going to next add my error bars, then I'll add my titles. So I go to Layout, Error Bars, More Error Bar Options. And instantly I have this dialog box pop up, and then I have the error bars popping up. So this is on vertical right now, and I want to change my vertical. Well, the error bars, the vertical error bars, show me the uncertainty in the y quantity. That's the uncertainty in the average final velocity. That's this. That's what I should have as the uncertainty. And it's a different value for each data point. So here's what you do to use these values for the corresponding data points as the vertical error bars. Click Custom, Specify Value. The most that these could be off by, these values, in the positive direction is this. So you highlight it. And when you highlight this range, Excel instantly assigns 0.2 as the max that this data point could be off by, that this y value could be off by. And likewise, it uses this value, or this value, as the positive error bar for this y value. So it does that automatically. Really cool. And then negative error bars, this is also the same as what we have. It's plus or minus 0.2. Hit OK. And now they've been fixed. Before I hit close, I'm actually just going to click on the horizontal error bar. And look, now I'm looking at horizontal error bars instead of vertical. So my horizontal error bars tell me the uncertainty in the x quantity. And my x quantity, my independent variable, is mass. The uncertainty is a fixed value of plus or minus 0.3. So I come down here and I do 0.3, close, and I'm done. You notice that the vertical error bars are too small to see, so you state that somewhere in your report and just state it somewhere near this graph, right before or after the graph. So you see instantly, I'm not going to be able to use vertical error bars to find the max and min slopes once I have a linear graph. Instead, I'm going to have to use these horizontal error bars. So this graph is not linear, so I cannot add my max and min slopes. But if this were the linear graph, this would be the min slope, right? And this would be the max slope. I would connect this point to this. But this is wrong, and I can't do this because I do not have yet a linear graph. There's a little curvature here. Okay, now I'm going to add some titles. You go to Layout, Chart Title, Above Chart, and then you do Axis Titles, Horizontal and Vertical. I'm going to do a rotated vertical title. The Y quantity is velocity, average final velocity, I better say final velocity meters per second. The horizontal axis, well, the x quantity is mass, the independent variable. Mass, and it's in grams. For my chart title, I'm uncreative, so I'm just going to do y quantity velocity, and I'm being lazy and abbreviating velocity. Okay, I'll go back. Velocity. Okay, there's my first graph. Next thing I have to do is try to linearize my data. So I'm going to start by creating a log-log graph because I suspect some sort of power relation. So to produce a log-log graph, I need log-log values. So in this column, I'm going to do equals log of mass. And I'm going to copy this all the way down, and I'm going to add my border. And the header here then is log of mass, like that. And I'm going to center, make it look pretty. I want these to be the same cell, so I merge and center. And I center. Give it a border. Since I've already got my formatting, I'm just going to copy this over, Control-C, and then I'm going to paste it. But instead of log mass, this is going to be log of final velocity. But it's not just final velocity, it's average final. So let me plug in average. And I'm going to make this a subscript. Click font arrow, subscript. I'm going to italicize everything here, Control-I. And I'm going to italicize M. Good. These values should be log of here, right? And now I'm going to drag this down, copy and paste. Oops, it messed up my formatting, so I clear my borders, no border. Then I just add the outside border. Good. Might as well center these values while we're at it. Technically, these should have 2 sig figs. So you can correct this if you'd like, but I will not be counting off for this. The log of v values should have 4 sig figs, because that's how many average velocity has. So let's get this down to 4 sig figs. Now I'm going to create a new chart, so I'm going to click and drag, holding Control. That copies what I have. This will be log of velocity average versus log of mass. Whoops, not love mass, log mass. And I'm going to come here, highlight average, and again, font, arrow, subscript. Might as well make these italics. Fancy stuff here. Italics. So this then, I'm going to copy log v average, Control-C, and I'm just going to paste right here. Since that's my y quantity, I'm going to copy log m, paste onto the x-axis. That's my x quantity. Oops, it made it huge, so I'm going to do keep text only, and that makes it small. I need to get rid of my error bars, because we don't put those onto a log-log graph. And now I'm going to slide from final average final velocity. I want my y quantity to be log of average velocity. And this I move over to log of mass. Right? And look, I need to get rid of those error bars. They popped up. I thought they were gone. I can't really tell whether this is a straight line or not, because all of my data is so scrunched vertically. So I'm going to change my axis so that instead of starting at 0, it starts at like maybe 1.15. So I go to Layout, Axes, Vertical, More Options. Instead of the minimum being automatically generated, I'm going to set it at a fixed value of 1.15. Why not? And now I see there is some curvature here. Not a ton, but there is some curvature. So what I want to do then is I want to test for, I'm going to move this graph down and this over. I want to test for a consistent offset in all values of v, right? All values of v. Here's how I do that. I come back down. I say, look, if I drew my best fit line, my curved best fit line into this graph, my initial graph, then I think the slope-intercept would be around, I don't know, around 11 probably. And I would have to draw that in, scan my drawn graph into the computer, and paste it in my report. But right now I'm just going to estimate that it's about 11. Okay. So what that means is I'm going to copy and paste. I'm going to create a column of data where I subtract 11 meters per second, that's the y-intercept, from every value of v, and I take the log of that, like this. And let me unitalicize this. Okay, so what I need then is log of v minus the slope-intercept of my initial graph, which is 11. And I copy it down. Fix the formatting. And here we are. So now I'm going to copy this graph, reproduce it, make a copy. And instead of log of v, I'm doing log of v minus 11. And might as well put units, meters per second. I'll copy this, paste it into my y-axis title. Alright, and now I click on a data point, and I click again so I have just one selected, and I slide this over. And it's straight, but I need to fix this. Let me go to Layout, Axes, Primary, Vertical, More Options, and now they can auto-generate that again. So let's add a trend line. I right-click on a data point, add trend line, display equation. Right? That's a nice straight line. I've done it. The fact that this graph makes a straight line instantly tells me, I instantly know from this straight line graph that there is a consistent offset in all values of v average equal in value to 11 meters per second. Okay? And I also know that this is the consistent offset in all values of v average. And I know that there's a power relation between v average, my dependent variable, and mass, my independent variable. Right? So in the next video, I'm going to show you how to define that equation, define that function, that power function or power relation, and write a final equation. And I'll show you how to create a final graph with propagated error bars which tests that equation.